In this video, I'm going to talk about something called a quotient rule. And this is another way for us to find derivatives with some ease. We could maybe do, this first one, 1 over gx prime, through the power rule, but it can get very tedious. So, there's some easy ways for us to memorize some, these are because you can just memorize the product rule as well. And it'll help you, right? It'll make your life easier. So, the quotient rule. I'll erase these question marks and I'll just write it down what they are. So if we had a 1 over gx, 1 over whatever, some function, right, and we wanted to find the derivative of that, that would simply just be negative g prime of x over g of x squared. I know, very odd, but it'll all make sense in a second. And this one would just be f prime of x multiplied by g of x minus f of x g multiplied by g prime of x all over g of x, and this guy being squared. So the numerator in this one looks sort of similar to product rule, except we have a minus sign instead of a plus sign. And then and obviously there's a denominator where it's g of x squared. So there's a derivation of this well. It's not some made up thing. So I said let y equal 1 over g of x. I used the difference quotient once again, just subbed it in. I factored out in step 3 here. I took out 1 over h to leave it as g of x plus h minus g of x. I just gave them all the same common denominators, basic fraction stuff. Here in step 4, I just made them all have the same denominator. And then in step 5, I took out a negative to make it sort of look like g of x plus h minus g of x, because remember in the limit formula, right, it's some function x plus h minus that over h gives us the derivative. So I'm trying to accomplish that here. I split up the fraction. I bring the 1 over h into the mix and put it here. So I'm just splitting up the fraction, not doing anything too weird here in step 6. And then I just multiply everything by the limit. And now you'll see that, in this first chunk, right, as h approaches 0, this becomes 0. So this is just g of x times g of x, which is g of x squared, and this is negative 1. And this is what I wanted, and then I got g prime of x. So this simplifies to g prime of x over g of x squared. This one, I just went a little cheeky. Since I had already solved this one, I just sort of plugged it in. So in f of x, or and g of x prime, I just split it up. I split up the fraction here in step 1. Then I use the product rule. This is the product rule. To achieve this, I use the product rule, right? Hopefully you can see that. This is, f prime of x times, the g of x, but this is just 1 over g of x. And I could have, worked this all out in one giant step, but I chose not to. I chose to substitute in for 1 over g of x prime because I just figured that out right here. And it gives me this, right? Right? That's what I've been solving. So I just was like, all right, let's just plug that in. And then this, the green highlights, I plugged it in. Right? And then I gave everything the same denominator, worked it out, and it leads you to this. So yeah, I didn't want to go through again, like in the last video I said, I don't want to go through every single step of the derivation. I just wanted to show you that there is some proof behind it. You can always rewind or take a screenshot. I'll give you the opportunity to take a screenshot right now of this one and of this one, if you do choose to do so. All right, so hopefully you wrote those rules down. Let's get into the practice. Let's do some practice examples. First one, I'm just gonna, what was that? I'm just gonna put an arrow here and write it. So y prime equals 2. Now we're gonna use that second one we just did, which is f of x over g of x prime gives us that wonderful stuff. So I'm gonna take this one slow, x, differentiating this, and then times 3x minus 1, right, because I'm making this my f of x this is my g of x, right? Minus x and then 3x minus 1, differentiating that. The denominator, 3x minus 1, squaring that. The differentiating x is just 1 times 3x, 3x minus 1, so I'll just make this 3x minus 1 minus, this just becomes x multiplied by 3, right? 3x minus 1 differentiated, 3x minus 1 squared, and then 3 of x minus 1 minus 3 of x, right? Just expressing like that, 3 of x minus 1 squared. And you end up getting 3 of x minus 3 of x, that just leaves, that's 0, so you just end up with negative 1 over 3 of x minus 1. That is the derivative of this example. Let's go to the next example. Pause the video and see if you can actually do this. So y prime equals 2. Now, you could use the f of x over g of x prime quotient rule, but you can use the 1 over g of x prime as well. You can actually just use that. Instead of the 1 now, you just have a 3. So this would be 1. So you know, I'll just write it. So you know how it's 1 over g of x prime? You can totally use it for here. So how's it going to look like when you use it over here? Well, let's start off with this. So there's a negative sign, and then there's a 3, and then there's going to be an x squared plus 1, differentiating this over x squared plus 1 squared. This then becomes 3 times, well, that's just 2x, and then that 1 is a constant, so it's a 0, x squared plus 1 squared, and you end up getting negative 6x over x squared plus 1 squared. So not too bad, right? Pretty straightforward, hopefully. Let's do question 3. This one's a bit of a doozy. So I'm just going to write it on the side here. Okay, y prime. So I'm just going to take a shortcut. I'm just going to differentiate the top part first. Instead of writing it, I'm going to differentiate. So that's just 4x minus 3 times x squared plus 2. Again, 4x minus 3 is just this guy, but differentiated. All right, so x plus 2 minus 2x squared minus 3x plus 5, x squared plus 2, all over x squared plus 2 squared. Y prime equals to, I'm just going to expand, so expand this first stuff on the left. So 4x times x squared, 4x cubed, 3x squared minus 6. Oh, silly me. I forgot to differentiate this. That's just 2x. 2 times 2, 4x cubed, bracket, 12x squared plus 10x, close bracket, all over this. Let me zoom out a little. Okay, 4x cubed minus 4x cubed, right, because there's a negative here. Negative 3x squared minus 12x squared, so that just gives you 9x squared. Right, and oh, oops, no, I had a feeling I did something wrong. Why is this? This isn't 12. 2 times 3 is 6. Apologies. I had a bit of a brain fart there. Anyways, so 4x cubed minus 4x cubed is 0. Then this negative 3x squared minus a negative 6x squared, so minus minus, that becomes positive. So that just becomes 3x squared. Then we have an 8x over here, minus a 10x, so that just becomes negative 2x, right? The 10x is here, but it's multiplying by the negative 1. And then we just have a negative 6 all over x squared plus 2 squared. So that is the derivative. 3x squared minus 2x minus 6 over x squared plus 2 squared. try graphing that and see how interesting it looks. All right, last one. I'm just going to write this on the side here. I did not leave myself enough room once again. So before we start differentiating, let's just simplify the top real quick. So that would be x cubed minus x squared plus x minus 1. So x cubed minus x squared plus x minus 1 all over x cubed. Differentiating this, we get, I'm just going to get straight into it, 3x squared minus 2x plus 1 x cubed minus x cubed minus x squared plus x minus 1. Differentiating, x cubed becomes 3x squared all over x cubed being squared, which is just, so let's do the top first. So 3x squared, so that is 3x5 minus 2x4 plus x cubed minus 3x5 minus 3x4 plus 3x3 minus 3x squared, right? All over x to the 6th power. Okay, let's do some canceling out. 3x5 minus 3x5, that's 0. Negative 2x4 minus negative 3x4, that becomes positive x4. So we can write that down. X cubed over here, subtracting 3x cubed, that becomes negative 2x cubed. And then this just becomes plus, because minus negative 3x squared just becomes plus 3x squared over x6. And we're not done yet because we can do a little simplification, right? We see everything has an x term, and the least we can reduce by seems to be an x to the 2. So this would be x squared minus 2x plus 3 over x4. So x squared minus 2x plus 3 over x4. That is the derivative of this lovely guy, question 4. And yeah, that's pretty much it. Quotient rule, not too bad. Sort of similar to product rule. Hopefully this video helped. Let me know down. I can't talk today. Let me know down in the video if you have any specific questions you would like. I can maybe make a video on that, or you got any feedback. Hopefully these videos help you. But yeah, that's pretty much it.